The Harben Century Series pump is a radial piston pump capable of pressures up to 828 bar and flows of up to 155 litres per minute. It has a worldwide reputation for reliability and performance and is, if the instructions in this video are followed, a straightforward pump to service and strip. This video explains the procedure for servicing, stripping and rebuilding of the pump, as well as fault finding. For the purpose of this video, the work was carried out on a pump stand. In normal circumstances, a pump service would be carried out on the unit. A strip down, however, would necessitate removal of the pump head. The pump we're working on here is an 8-cylinder Century pump head. It should be noted that if the pump only requires a service, it is not necessary to split the crankcase or remove the barrels. You may not always want to go through the whole video to find the parts you want to see. We have therefore indexed sections of the video, such as preparation for service and strip down, inlet and delivery nut removal, splitting of crankcase, diaphragm removal, barrel removal, center assembly removal, valve and diaphragm fault find, diaphragm protection valve, reassembly of center assembly, replacing barrels, replacing crankcase lid, replacing valves and diaphragms, replacing manifolds and bell housing, oil and water bleed, Mark II Century selector, Century land gun, and unit fault find. At the end of the video, there is a short section on how to service and diagnose faults in the Century selector and the Century land gun. To begin, any water is drained via the plug at the bottom of the inlet manifold. The oil plug, in an adjacent position on the bottom of the crankcase, is then undone and the pump oil also drained. Once the pump has been drained and taken off the machine, the pump drive coupling needs to be removed. The retaining bolt is taken out and a coupling puller is used to remove the coupling and counterbalance weight from the pump drive shaft. Two set screws are used. These screw down through the puller into the coupling before the coupling puller screw is tightened down. The procedure is repeated using longer set screws for the counterbalance removal. It's now a straightforward task to undo the bell housing nuts and to remove the bell housing. The next step is to undo the banjo bolts on the delivery manifold. With the banjo bolts removed, the delivery manifold can be eased off. The key is then removed from the shaft. The pump inlet manifold is next to be removed by undoing the manifold nuts. The large inlet nuts on all the barrels now need to be unscrewed using a slogging spanner. When removing the inlet nuts, they'll sometimes come out with the inlet nut collar. Otherwise, the collar will sit in the neck of the barrel, as shown here. We now move on to the delivery side of the pump to remove the oil bleed rings and screws. The delivery nuts and valves are removed using a slogging spanner. Remove the 8 nuts from the crankcase bolts on the inlet side of the pump. In order to split the crankcase, the bolts on the delivery side are loosened in sequence before being tapped with a nylon hammer to separate the crankcase halves. As soon as these halves begin to separate, the crankcase bolts are loosened further and tapped down once again. The crankcase half is then free to be pulled out and the spacer tubes and their bolts removed. A nylon drift is used in the next stage to remove both the mandrel and the diaphragm. The drift is placed onto the top of the mandrel and tapped out. Next, to the center assembly and the removal of the first retaining ring and its circlip. It's now possible to remove all the barrels and pistons from the crankcase by undoing the set screws shown here, which locate into the barrel body. The next step is to remove the disc spring, shaft bolt, and the drive cap. With this job completed, the main bearing with pressed-in eccentric and second retaining ring can be simply pulled off the pump shaft. The crankcase half is then pulled off the stand, leaving the shaft behind. To remove the oil seal, take off the carrier by undoing the 4 nuts shown here. Then check the O-ring and press the oil seal out if required. The bearing is held in place by a circlip and can also be pressed out if it needs to be replaced. On the other half of the crankcase, the drive cap housing can be removed in a similar way if the floating bearing needs to be pressed out. The delivery valve, which sits inside the delivery nut, is pushed out using a drift. The valve components must be checked for wear and damage, such as pitting and cavitation. The guide, stainless steel ball and valve seat, as well as the O-ring in the delivery nut itself. The inlet valve assembly sits in the base of the mandrel. Again, check should be made to the valve seat, its O-ring and backup ring, the valve plug, and the spring. The mandrel itself should also be carefully checked to ensure the roll pin is not obstructing the valve plug. Also, check the O-ring and the backup ring on the mandrel. The diaphragms must also be checked. Here we show 2 possible diaphragm failures and their explanations. Shear failure is due to excessive running hours. To remedy, check all diaphragms and valves and replace where necessary. Pinhole failure could be due to A. Inlet restriction, either through blocked filters or kinked inlet hose. B. Worn or damaged inlet valves. C. Excessive inlet hose length. Or D. The pump having been frozen. If this failure occurs, you should A. Clear restriction on the inlet. B. Check inlet valves. C. Check diaphragms. And D. Replenish oil. To separate the mandrel from the diaphragm, a tool called a mandrel diaphragm separator is recommended. It makes light work of the job and does not damage the components. Once removed, the mandrel pins can be checked from the outside. We now return to the barrel assembly and must first check the condition of the diaphragm protection valve. The retaining socket screw is taken out, then the inner cylinder is unscrewed and removed, along with the slipper and piston assembly. The diaphragm protection valve assembly consists of a spring, a valve, and a seat, and they need to be carefully inspected and cleaned, and the O-rings replaced if necessary, before the reassembly procedure can take place. The cylinder nut should be screwed back into the barrel and torqued to 680 Newton meters, and the socket screw tightened. A drift is then gently used to ensure that the diaphragm protection valve touches down onto the seat, and the piston and slipper is carefully reinserted. When stripping the pump, it's most important to keep each barrel assembly's components together and in order, as shown here. This is to assist in fault finding. Before the barrels can be reinserted into the crankcase, the oil seal carrier has to be replaced onto the crankcase. The inner base must be greased and the O-ring put back in. The carrier is now ready to be bolted back down. The crankcase half is then lowered over the shaft, which is located into the pump stand. It's now a straightforward procedure to put back the main bearing with pressed-in eccentric and first retaining ring. This is followed by the shaft cap and bolt, which is fixed with a small amount of Loctite. The bolt is then tightened down to approximately 135 Newton meters. The disc spring is placed over the drive cap. The barrel assemblies are now ready to go back into their respective positions within the crankcase. As with the P-pump, the barrels are letter-coded and must be put back in the correct order. The O-rings around the barrel should also be checked. Here you can see the hole in the barrel assembly, which is designed to locate onto the shear pin mounted into the crankcase, as demonstrated here. The set screw, which locates into the barrel assembly, must be replaced now, but not tightened yet. The crankcase bolts and their spacers can now be put back in, followed by the retaining ring and its circlip over the center assembly. Before reassembling the crankcase, the rim and the O-ring need to be liberally greased. The other crankcase half can now be eased over the barrels. Once in position, the crankcase bolts should be screwed down evenly to ensure that the two halves are drawn together properly. To finish, the protruding crankcase bolts should be greased and the nuts screwed back on. Now, tighten the barrel retaining set screws then replace the oil bleed rings and tighten the bleed ring nipples. The delivery valves can now be reassembled with the O-ring, guide, stainless steel ball and seat. And tap down into place before being reinserted into the delivery side of the barrel. It's recommended that threads are greased at this stage. The delivery valve nuts must be torqued down to 340 Newton meters. Next, the diaphragm and mandrel. The diaphragm should first be oiled or greased and the mandrel's neck inserted. A dolly and a hammer is used to knock the mandrel fully back into the diaphragm. The inlet valve can now be reassembled. The spring inside the plug, followed by the seat, are inserted into the base of the mandrel. The outside of the diaphragm is oiled and put back into the inlet side of the barrel using a nylon drift to push it fully back into position. The inlet nut and collar are greased and screwed back into their respective barrels. Finally, the nut is torqued down to 814 Newton meters. The inlet manifold is now ready to go back on. First, the O-ring groove is greased, and then the manifold carefully slid back onto the crankcase. The manifold stud ends are greased, the nuts replaced and tightened down. Again, the nuts should be tightened in sequence, as demonstrated. Back to the delivery side of the pump and the reassembling of the delivery manifold. To begin, the doughty seals are put back into the delivery nuts and the manifold relocated back down onto the pump. After greasing, the banjo bolts are put back into position to secure the manifold. The two banjo bolts with air bleed nipples are replaced at the top of the pump. The bolts must be torqued down to 270 Newton meters. Before replacing the bell housing, the shaft key must be put back into the keyway. The bell housing can now be replaced and secured. Here we see the bell housing washers and nuts being replaced and tightened down. The next stage is to replace the counterbalance and the drive half coupling. Once in position, the drive cap must be replaced. It's located with a pin, shown here, and a socket screw, which is first coated with Loctite. Finally, the crankcase oil plug and inlet manifold drain plug are replaced. The pump oil is replaced via the filler cap on the top of the pump and mounted back onto the prime mover. Once in position, the pump must be bled. First, the oil bleed screws working from the bottom upwards to dispel all the air from the crankcase. Then the two water bleed screws at the top of the pump to again dispel any air. During the oil and water bleed procedure, the pump must be operating in the dump mode. The pump is now ready to be run up to pressure. The Mark II Century selector, shown here, is mounted on a trailer-type DTH 150 unit and is easily accessible for servicing. The selector is used on the machine to switch between the high pressure and dump modes. The first step is to disconnect the selector lever by removing the clevis pin and clip. The retaining nut is then undone, and the spindle assembly tapped down and out of the selector body with a nylon drift. The selector contents can now be checked. The glands, seats and collars are carefully removed from the spindle, enabling us to look at the spindle PTFE O-ring. Here we can see the PTFE O-ring is split and needs to be replaced. The spindle seals must also be checked. To fit a new PTFE O-ring, this special assembly tool must be used to stretch the O-ring over the spindle. A specially adapted pusher is then used to contract and locate the O-ring into its correct slot on the spindle. The selector components are now ready to be reassembled. Components should be laid out in order to assist the reassembly procedure. The spindle is first greased, and the glands, collars and seats replaced in the correct order. Once assembled, they are finally greased before reinsertion into the selector body. The retaining nut is greased and then replaced into the bottom of the selector. It's now a simple task to reconnect the lever with its pin and clip before the retaining nut is tightened back up. After servicing the selector, the machine must be started in the high pressure position to energize the new seals. To begin the service of the Century land gun, the handle and trigger assembly must first be removed. The gun body cap is completely undone and the gun's contents removed with the use of a nylon drift. The glands, collars, seats and spacers are taken off the spindle and laid out in their correct order to assist the reassembly procedure. Both inner and outer seals must be carefully checked and, if necessary, replaced. We can now commence the reassembly procedure by replacing the components back onto the spindle in the correct order. The assembly is then reinserted back into the gun body using the nylon drift. The cap is then replaced and torqued to 41 Newton meters. Finally, the trigger and handle are replaced to complete the service procedure. The gun is now ready to be tested. The most common type of fault likely to occur is loss of system pressure. This usually causes vibration whilst jetting, as demonstrated here, and a drop in the water pressure reading. The first checks are to the oil and water bleed procedures. If this doesn't cure the fault, further checks must be made to the inlet water supply, including the filter, for blockages and damage, also to the inlet line for restrictions, and to the water tank strainer. It's also possible to check whether a diaphragm protection valve is lifted by undoing the oil bleed nipples on the barrels. If no oil comes out, the fault will lie with the diaphragm protection valve. In the event of high system pressure, the safety relief valve will lift. This can be caused by an incorrect or blocked nozzle, or by a restriction in the hose, and possibly the wrong hose bore. For further in-depth fault-finding procedures, refer to the fault-finding section in the Harben service manual. It's recommended that all service work is done in conjunction with the Harben service manual, and that only genuine Harben parts are used. If you come across any further difficulties not covered by either the manual or this video, we would recommend you contact your nearest Harben distributor or the main factory for further assistance.